Today we're going to be dealing with solving equations with variables on both sides, but we're going to be going a little bit deeper with it. So instead of getting into the stuff we've already done, we're going to actually have a couple different options for our answers. As a reminder, when we are solving equations, we want to work the order of operations backwards. So we want to do Sally, Aunt, Dear, My, Excuse, Please, or SADMEP, which means your first step is to collect all your variables on one side of the equation. Secondly, combine any like terms. Remember, just like the Halloween stuff we've talked about, like terms are where you have x's with a couple things, or if you have numbers by themselves with a couple things. They need to be on the same side of the equal sign before you can combine them. Step 3, undo any addition and subtraction that's happening to your variable. And step 4, you need to undo any multiplication or division happening to your variable. Keep in mind the goal is to isolate or get your variable by itself. Now this is a problem you did on an earlier video. So I'm going to start out by distributing this 1/5. So I've got 4x minus 5, and then I'm going to take 1/5 times each piece. 1/5, when I multiply by that, that multiplies by the numerator and divides by the denominator. So 5 times 1 is 5, divided by 5 is 1. So that's 1x, or x. Then I'm going to distribute to the 20. 20 times 1 is 20, divided by 5 is 4. So I've got x plus 4 on the right. From this point, we need to get all our x's on the same side. I can either get rid of this positive x by subtracting x from each side, or I can get rid of this positive 4x by subtracting 4x from each side. Both will work, but I really recommend subtracting x from each side because that's going to keep your terms positive. Once I do that, I'll be left with 3x minus 5. X minus x is 0, so those cancel. And I'm going to bring down my positive 4. Now it's a two-step equation. I'm going to undo any addition and subtraction. 5 is subtracting with x, so the inverse, or the opposite of subtracting 5, is adding it to each side. Those cancel, and I'm left with 3x equaling 4 plus 5 is 9. The inverse of multiplying both sides by 3 is dividing both sides by 3. And the inverse of multiplying is dividing, so I'm going to divide both sides by 3. And I'm left with x equaling 3. Remember, if you get one answer like this, you can always substitute it back into your original problem and check to make sure you've done it correctly. On the left side, 4 times 3 is 12. 12 minus 5 is 7. On this side, 5 times 3 is 15. 15 plus 20 is 35. 35 times 1/5. Well, 35 times 1 is 35, divided by 5 is 7. Since both sides equal 7, they equal the same thing, my equation works. So I have the correct answer. Let's look at this one. 5x minus 6 equals 5 times x minus 1. So I've got 5x minus 6 on the left. I'm going to distribute on the right. So I've got 5x minus 6 and 5x minus 5. Collect your variables on each side, so I'm going to subtract 5x from each side to get rid of that positive 5x. Five x minus 5x is 0, so I'm left with a negative 6 on the left. 5x minus 5x is 0, so I'm left with a negative 5 on the right. Oh, hang on, all my x's are gone. So now let's look at this. If I've got negative 6 equals negative 5, is that something that's true? No, negative 6 is not going to equal negative 5. It's never going to equal negative 5. So this is something called no solutions. There is no number in the history or future of numbers that can ever work to make this equation work. So anytime you cancel out all your x's and you've just got a number equals a different number, it's no solutions. Let's look at this one. Distribute on each side here. I'm going to type and see if that's a little faster. 4 times 3x is 12x. 4 times 2 is 8. On the right side, 2 times 6x is 12x. 2 times 4 is 8. Then I'm going to subtract 12x from each side. Once I do that, 12x minus 12x is 0, so I'm left with 8. 12x minus 12x is 0, so I'm left with 8. And again, all my variables went away. I've got 8 equals 8. Is that something that's true? Yeah, 8 equals 8. 8 always equals 8. If I've got $8 in my pocket, that equals $8. So this is an identity. It's an equation that's true for all variables. So you would write as your answer to this all real numbers. Or you can make the infinity sign, which is an 8 turned on its side. So either of those would be acceptable answers. Now you don't actually have to work out a problem completely to decide if or how many solutions you're going to have. First you need to ask yourself, do you have the same number of x's on each side? For that you're either going to have a yes or no answer. If it's no, then you have one solution, because that means you've got something like 4x plus 8 equals 13x minus 7. You have one solution because you'll subtract your 4x's from each side and you'll find out that you have x equals some number. If the answer is yes, you have to ask yourself another question. Do you have the same number that's added or subtracted with your x? If the answer is yes, you have infinite solutions or all real numbers. So that would be like 3x plus 2 equals 3x plus 2. If you subtract away your x's, you're left with something true, or 2 equals 2. If the answer is no, then you have no solutions. That would be something like 3x plus 2 equals 3x plus 15. Once you subtract your 3x's away, you've got 2 equals 15. That doesn't work, and it will never work. 2 is never going to equal 15, so that will be no solutions. For your homework tonight, you have to come up with 3 of your own equations. You're going to make one per type. So make an equation that has an answer that would be all real numbers, an equation that has one solution, and an equation that has no solutions. You do not actually have to work these out. I would use the tips on the last slide to help you out. Have a great day.